Hello everyone, it's time for us to start. I want to introduce myself first. My name is Yuval Bahar. I'm a principal engineer in LinkedIn and the president of the Open19 Foundation. I want to welcome you for the webinar, and hopefully this webinar will be helpful for you and will enable you to connect better with the Open19 project and the foundation. On the agenda for today, we're going to take a look a little bit about data center view of how Open19 is optimizing data center. We'll talk about the goals of the Open19 project and a deep dive on the technology of Open19. We'll talk about project status, the Open19 Foundation, and then we'll open it up for Q&A. Just a few logistical aspects before we start. Please mute your phone or your computer for the duration of the webinar. We will open it up for Q&A at the end of the webinar. Please hold the questions to the end of the webinar. And if you have questions, please type them in the chat window and put your name on the chat window so we can reference you to the when we actually open up the question, so you can actually unmute yourself to be able to talk to the question that you have. If you do a chat discussion, please keep it personal if you need to, or if you need to make it a chat for the whole group, just run it with the whole group. Questions needs to go to everybody so everybody can read them. And let's jump in. Let's talk a little bit about data center philosophy. When we started the Open19 project at LinkedIn, we had a very specific philosophy we're looking at to be able to create a very unique data center solution. I think the first element that we looked at was we wanted to make sure that every element in a data center is look like and behaves like a server. If it's a switch, it's a server with a lot of ports. If it's a compute server, it's a compute server with a lot of processing power. If it's a storage server, it's a server with a lot of storage around it, but that's it, it's all servers. And that is very essential to the way we actually build the architecture. We wanted to go to a data center when we don't have appliances. And it goes back to the first comment about if we don't have appliances, then everything looks like a server. That's completely okay. And every solution is a solution which is software-based, either managed by software or run by software. For every element in the data center, we wanted to create multi-supplier option, and we'll show how we did this in a second. And we want to solve in software what we can. What we can solve in software, we want to solve in software, and we don't want to impose a hardware solution. Example for that is distributed firewall that we would like to actually implement in software always at the endpoints instead of creating choke points on our network. We wanted to create flash as a storage, as a baseline for storage. We see the future going to high performance storage and mid-tier storage, which will be flash based, and this is our focus. We wanted to build a solution that will be living in a world of scale out. And what does scale out mean? Scale out means that the more you need to have, you just replicate what you have and you create more of them, and you don't need to increase the size or the power of a single element. You just need to add more elements to scale your systems. Disaggregation is an interesting term. It has different meanings for different people, but what we mean in disaggregation means every element is independent. There's no element which actually covers a significant portion of the data center or of even a rack. Every element in the rack in the data center is completely independent. And lastly, we wanted to make the data center as cost optimized as possible. From our perspective, cost is important because everything is replicated in thousands, tens of thousands, or hundreds of thousands of times. The cost is extremely essential for us. As a result of those set of goals, we actually kicked off a project called the Open19 Project. The project was kicked off about 2 years ago, and it started initially with developing architecture and then moved into actual implementation of different elements in it. We have about 9 different sub-projects in the Open19 projects. I'll touch on most of them right now, and I'll also show the path how you can actually start using the technology in your areas. Take a pause over here for a second. Seems like there's a problem. I don't know who guest 3 is, but if wherever you are, please do not share your screen. Please do not open your video, or do not, and also do not play with the sharing of the project. Okay. Thank you. Okay, going back to our discussion. So the Open19 project. So we set a few goals when we started the Open19 project. We wanted to create an open standard that can fit into 19-inch rack environment for server storage and networking. The reason that we picked 19 inches as our baseline, the baseline of our Open19 says, okay, if we need to go to a diverse environment, the diverse environment can be anything between a POP, an edge platform, a small data center, large data center, or mega data centers. The one thing which is common for all of those elements is a 19-inch rack. So we wanted to drive an environment that our solution will always be able to fit into any place. A 19-inch rack is the baseline. That was a goal which is really strong for us because we have at LinkedIn a very diversified environment, and we found afterwards that a lot of our partners are actually operating in this diversified environment. Second, we wanted to create a solution that would be applicable for any size. We have a solution that we want to drive into small data centers, which are in the tens to hundreds of servers, but at the same time, we want to drive into a very large environment where we'll be able to actually drive tens and hundreds of thousands of elements into a data center with the same technology. And we want to share the volume that we get from the high size, large environment into the small ones. We wanted to optimize the way we do rack deployment. And one thing we were trying to solve is that we wanted to be in a position that we can get into an environment where we have a solution which is optimized in solving the operational problem. A lot of challenges in data centers is how to build data centers, is rack and rolling, not rack and rolling, on-site deployments or not on-site. We said we wanted to do rack deployment cost optimization and rack deployment integration optimization, so it would be fast and cheap to actually be able to build racks. We had a target of 50% reduction on commons of the rack, which we can say we achieved. And we had a target of 3 to 5x faster integration time. We can very well say now that we actually exceeded that target, and we're at 7 to 8x faster of integration in a rack. And lastly, we wanted to create an ecosystem. We understood at that time that we have to be in a position that we have partners and other companies which adopt the technology across the board in different sizes and different formats. And to do that, we have to build an ecosystem, and that was part of the reason that we built the Open19 Foundation. Let's jump in directly into the building blocks of the Open19 platform. What you're seeing in the picture over here is a 19-inch rack that has in it 4 elements that we call cages. Those cages are elements which are defining the form factor for the servers. The servers we call bricks, and we have 4 sizes of bricks. A single standard brick, which we call a half width, 1 RU. A double wide brick, which is a brick which can take full RU. A double high brick. And we have a specialty brick which does not show in this picture, which is a half width 2U, which is more targeted into an environment where you can do a lot of modules into a high density environment. We have 2 elements which are shared over here. One is a network switch, which we created a special one, but is an optional to use. And the other one is a PowerShell, which is doing a highly optimized, very power efficient distribution of power in the rack. Every 2 cages over here in this picture have 1 common switch and 1 common PowerShell. And in this picture that you see over here, we actually integrated 2 of those sets, what we call leaf zones, into a single rack. To do that with a full 12 RU cage, you need a 52 RU rack to do that. If your rack is smaller than that, you can do a combination of 12 and 8 and build a smaller form factor. Now, if you look at the back side of the cage, this is where we did something which is a little bit special. We created a blind made connection with snap-on cables. The cables that you see over there is the data cables. This is just a schematic view of it. I'll show in a minute a clear picture of that. What it does is actually connects to the passive cage and creates an environment of blind made connectivity for the servers, for data and for power. Each one of those connectors represents 100 gigabits per second today at 25 gig signaling and 200 gig capable at 50 gig signaling. It's pre-designed and pre-tested for 200 gig per server, which we believe will take it for a while to be exhausted. On the power side, we enabled 400 watts for every brick, which means every half-width 1 RU server will get an entry level of 400 watts, and it will scale with size. This cabling system enabled us to create a system which is very, very easy to implement, very easy to integrate, and extremely simple for server integration afterwards, because the servers do not need to be cabled neither to a PDU nor to a switch. They are pre-cabled when you build the infrastructure, which is just the cages and the cables. If you go one level down into the subcomponents, the brick cage is a passive mechanical cage. All it does right now is defining a form factor for the servers. We have two versions of that cage, a 12 RU version and 8 RU version. Both of them are available and both of them are being completely tested right now. We have what we call 2 RU modularity. Every 2 RU can be modified to take 4 bricks, which are 4 elements which are half width 1 RU, 2 double high half width, so 2 elements which are 2 RU but only half width, 2 double wide, which means 2 elements which are 1 RU full width, and 1 double high 2 RU box. You can see the septum on the top picture, which can be removed in the field, does not have to be predefined or pre-manufactured. It can be removed in the field and to set up your configuration which appropriate for you at any point. The element that you see on the bottom is the back side of that cage. You can see the holes over there, which are called the snap-on holes, where the cables will actually fit into once this thing is installed in a rack. This is an example of the data cable, which is being produced by Molex. Molex is creating the data cables, and what you can see is that every element in the rack or in the cage gets a small connector which doing the 100 gig. Then we aggregate all this data, which is 12 channels of 100 gig, 1.2 terabit, into one large connector which goes into the Open19 special switch that I'll talk about in a second in more details. This is a high-level view. This is just the cable by itself. That cable is released to production, and you can order it already now from Molex. And this is just a little bit zoom in on the Impel connector and the breakout, the way it's being built. This connector is rated for 56 gigabits per second with PAM4 signaling. And each one of the servers is getting 8 channels, 4 transmit and 4 receive channels. So you can aggregate 200 gigabits per second for every server once the switch will support such bandwidth. If we look at the bricks and the server form factors, like I said, we have 4 form factors: a brick, a double wide brick, a double high half width brick, and a double high double wide brick, which is a 2U configuration. Important thing over here is that the bricks grow linearly. So the bigger the brick, the more data bandwidth it's getting and the more power. For example, if you look at the double wide brick, the double wide brick will get twice the power, which is 800 watts, and twice the data. So it can actually get day one 200 gigabits per second. The other element over here is self-sustained. these servers, once bought from the suppliers, will be self-sustained, meaning they have been already qualified for EMI, they have been qualified for safety, and they can self-cool. So they don't have any requirement in the rack level to actually cool themselves. They can actually be self-cooled on any temperature ranging on ambient between 15 and 45 degrees C, which means that in areas where we don't have a special rack that helps us cool the system or cool the environment, these servers will still survive as long as the ambient is between 15 and 45 degrees C. It has blind mate connection of 100 gig on the small version, going to 200 on the two middle servers, and going to 400 on the 2U solution, which is more targeted in some cases to storage, and in high performance storage that extra bandwidth for the network is required. If we look at the Open19 switch, first, this is an optional switch, so if you don't feel comfortable with switching into a special switch, you don't have to, and I'll explain in a minute how you don't have to. This is a 3.2 terabit switch. It has a dual switch in it. It has a dual data path 3.2 terabit switch, but it also has a management out-of-band switch. Because we're limited to a 3.2 terabit at this point from technology perspective, we only allocated 50 gig per server because the system can take 48 servers in this configuration. We used one of the extra channels for 1 gig out-of-band connection. It's optional, you don't have to use it. But if you will connect this 1 gig to the management port, you will be terminated into the switch that you see on the bottom left of the switch picture. And you also have an option to connect the console port on the 4th channel. This switch, the way it is right now, did not implement the console, but it is completely possible to implement this into a console. As you can see, the switch does not have a power supply in it because it's getting the 12-volt input from the PowerShell. And it has 8 standard 100 gigabits per second connection for uplinks or for components which are not Open19 in nature and still need to connect to the network aspect of the top of rack style. Then you'll have extra ports for that. It has a Broadwell DE CPU subsystem, which is really high-end for a CPU subsystem in most switches, and enables you to do very fast convergence on any other aspect. This is a white box design from LinkedIn, and we will open it up for the Open19 Foundation once we complete every test and release this to production. This is the PowerShell. This is a very important part of the Open19 project. The PowerShell you're seeing over here is a PowerShell from Delta. Delta is producing the PowerShell. The PowerShell has two main elements to it. One is the front 6 modules that can actually take, each and every one of them can take 3.2 kilowatts. And if you operate in a 3+3 mode configuration, that rates the PowerShell to 9.6 kilowatts. If you're okay with operating in a 5+1 configuration, you can push the limit of that power on that PowerShell, and by that enable the system to be able to go to a higher level, but then you give up a little bit on redundancy. There will be an optional 2RU 19.2 kilowatt system in the future. Currently, it's not being built. This is shared power modules, so you can actually use off-the-shelf power modules, which we picked over here, and share them with the 9.6 and the future 19.2. It has a management system with a GIGI port. The beauty of this shelf is completely universal. It's universal from an input voltage and an input type. It can go AC/DC on any range that you can have. And it has a generic connectors in the back which enable you to only change the whip connection, which means that the whip is the cable which goes from your outlet in the wall or in the ceiling or in the floor into the shelf. It can take delta, it can take Y, it can take AC, it can take DC. Any configuration in the US, Europe, or APAC has no difference. All of them will be able to work with the same PowerShell and the same power modules. The only thing you need to change is your whip, which is the cable that goes from your connection into the PowerShell itself. It has an optional BBU, so if you plan to use BBU, which is a battery backup unit, which you do put in the rack itself instead of your UPS system, it will be optional. Right now, it's not been tested in this way. Another element, 2 or more elements that I would like to emphasize about this PowerShell. This PowerShell is unique from a perspective that it's actually isolating every server in the rack to have separate protection and monitoring. Every element in the rack have separate EFUs which protects it from shorts or any faults, and even if a fault happens, there is no relationship between the servers. Each one of them is independent. Unlike solutions which are now in the industry, which are based on bus bars, when one element is at fault, it will actually take down the whole rack. In this configuration, every element is independent. It goes back to our concept of disaggregation, where we would like to have every element as independent as possible and not affecting the elements around it. The other thing for this, we have a dual BMC module inside, 2 CPUs which are running Linux environment, which will be open source running OpenBMC, and will enable you to actually, if you need to, write management system into that PowerShell, write code into the PowerShell itself, or connect to an API that will be defined in the future for the shelf to enable your management system to monitor, control, and drive the PowerShell from the outside. If you look at the installation process, it is extremely simple, and I'll show a video in a second of how the installation process is working. But you take any rack, you install the cages, install the PowerShell, the switches. From that point, you don't need tools anymore. Once these elements have been installed, you don't need tools anymore. You snap the cables, you plug in the shelf, you connect the switches, you blind made the bricks, and you go, and you're ready to go. And this is a good segue to showing how we actually implement this at LinkedIn. Just to summarize the benefits of this platform and to highlight a few elements over here. One is we go into any 19-inch rack. 2, it's fully redundant, so the system will never go down. There's no centralized rack level controller. There's no element which is centralized to any aspect of the rack. Every element is independent and working with no relationship to the element next to it. So a server in slot 1 has no idea what server in slot 2 is doing, and they have no relationship from a fault perspective or power consumption perspective or data connection. The system is fully disaggregated. As you've seen, every element is self-sustained and independent. We show in a minute an extremely short integration time. We're leveraging existing servers, which means every motherboard in the world can actually fit to one of our 4 form factors. We are over 96 power efficient. Thank you, Delta, for doing that. And we will be able to do a single step of conversion from 12 to load, which gives us a very efficient end-to-end solution. We are distributing 12 volt in this system, and one would ask why 12 volt and not 48. The reason for that is all servers in the world today, except a handful of servers, are actually getting a feed of 12 volts. And we thought that at this time, when servers are all 12 volts, it makes a lot of sense to distribute 12 volts and not to distribute a higher voltage. But in the future, since this is an extremely modular system, if we need to transition to a different power level, we can do that with just a different shelf that will actually distribute 48 instead of 12. Multi-server tiers, you've seen that we have different sizes of servers, and we will have, and I'll talk about this in a minute, we will have a variety of server suppliers that will give a variety of solutions. It's extremely cost effective. We have proven at LinkedIn that we have significant savings, tens of percents of savings, in actually making the system work. If we look at where we are from status perspective, this is a live picture. This is not a live picture, but it's a picture of Open19 live at our data center. What you're seeing over here is the infrastructure installed before we started installing servers. This is a full pod of 16 racks, fully loaded with Open19 gear. You can see the shelves, the power shelves, the switches, and the cages stacked across all of this pod. Let's look at the numbers a little bit. And I'll run the video in parallel so you can see it. Infrastructure takes us to build 75 to 90 minutes. Infrastructure, what we win is power shelves, switches, and cages and cables when it's completely ready. Server installation in the rack takes about 15 minutes. So total, it takes us about 100 minutes to do a rack with 2 technicians. And the video that you're seeing over here is 2 technicians in the LinkedIn lab doing this for the first time ever. It means that we can build a full cluster of 1,536 servers in 3 days. If we use servers which have quad sockets, 12 cores, and 6 containers per core, we have the staggering number of 442,000 containers that we can hand off from the moment we say go to our production in 3 days. This number is staggering. It's much, much faster than whatever we did before. And it a little bit eliminates the need to do rack and rolling in some cases, because we can do this much faster only with our on-site technician to do that, which requires minimal training. If you look at the video of what they're doing right now, some of the elements that you see them over here, like unwrapping the cables, etc., are being optimized, and the cables are coming extremely more optimized from a timing. So in reality, we will see much faster timing. What you see the team is doing right now is the team is actually installing the cables on the back for the snap-ons. You can see them snap into the back of the cages and preparing them to create blind made, as well as dropping from the ceiling the whip cables, which connecting, you see the pull of the whip cables from the ceiling, connecting the power into the power shelves and driving them into an element of an active infra. The next step over here is to plug in servers, but as you can see, this is the first build, an hour and 20 minutes. The system is up and running. Switches have been booted and PowerShells have been booted. This is incredible for us because it's much, much faster than anything we could have done before. If we look at this, the ownership by numbers, the bare rack savings is over 50% to us. We see a very, very significant savings. In a fully loaded environment, we see 35 to 40% savings, and that's including the servers. We are 4x more efficient if we use our quad solution, and we are 2x more higher density for power if we use our quad solution. And it's pretty clear to us right now that you can build a full cluster 7 to 8 times faster than what we were able to do before, which is for us is priceless. So if we look at the timeline, so all the cages have been released to production, both the 8RU and the 12RU. The 8RU is in final testing. It will go to production very soon. All the cables have been released to production. The only thing we're doing on them right now is cosmetics. We're trying to make them a little bit more beautiful. The bolt switch is dual sourced right now, and we're in the final pilot testing, and we'll be releasing to production in Q1 2018, which is this quarter. The PowerShelf is again in final pilot testing. We will be releasing it to production with Delta in Q1 of 2018. For the switches, by the way, the 2 sources that we have are Flex and Celestica, and they both can actually provide those. We will second source the PowerShelf in Q2 of 2018. Servers, currently we have 5 sources for servers, and this number is growing by the week. We hope to end up with about 8 sources for servers. Right now, there's 7 server types being in pre-production state and being tested at different environments and different configuration. All of those servers will go to full production in Q2 and Q3 of 2018. 5 committed suppliers will actually deliver servers for the Open19 platform. Let's talk a little bit about the foundation. The foundation was established in May of last year. The launch event was on the 23rd of May. It's a community-based organization, and the important thing of the Open19 Foundation is to enable to create a platform for everybody to come and share, develop together, or consume technology that will give you an option to be able to build as much as you want in the community, but to contribute as much as you feel comfortable with. You're not required to contribute, but you're encouraged to contribute. We have 5 founding members. It's HP, Enterprise, Flex, Vapor.io, GE Digital, and LinkedIn. And we have 30 corporate companies which are joining the foundation already, and over 1,500 individuals which joined as members. And this is only in about 7 months of work. This is a platform to share hardware and software, and it's done differently. It's done differently from a perspective that you share what you want, but if you don't want to share, you don't have to share. And we're establishing over here a de facto data center and edge standards for the future to be built across the industry. It's not just for LinkedIn. It has been built, and hopefully you were able to see from this presentation that it can be built to multiple aspects of data centers, from the edge to the core of the data center, in any size, in any form that you want, and it has a growth path in it as well to enable you to go to the next generation. The foundation itself has been built to enable us to create this open environment of development and to enable us to create a very collaborative environment between companies, which sometimes might be competing with each other, but will still be able to collaborate. In summary, Open19 is about defining a form factor. If you notice, we have not talked about a server. We talked only about a common form factor, a common environment for shared data and power connectivity, alignment connectivity, optimization of the technology, and the ability to be able to share technology from small to large. It's about collaboration in the community. Without creating the community, we couldn't actually build this solution. We have multiple companies which are direct partners to us. Flex is our primary partner, which was with us for the last 2 years and building with us the components and testing the components with us, and will be the first company that enable you to order it, and it's already available for proof of concept orders. So if you need hardware, you would like to start consuming hardware, you need to reach out to Flex and start getting request access for a proof of concept. Delta, which is building our PowerShell, which is incredible, and Celestica, which is joining us recently and second sourcing all of our technology to enable people to buy from 2 sources. The community is over 75 companies which are involved. Only 30 of them joined the foundation, but we hope the 75 will join the foundation in the near future. It's a group of data center operators and integrators, system suppliers and component suppliers. This group is the group that building the future. This is the group that building the data centers and the edge of the future, and this group will actually take us forward. Open19 technology is ready for the production, like I said, this quarter, so you can start thinking about doing proof of concept. If you want to join us as individuals or as companies, you can go to open19.org to the registration page and register as an individual for getting updates, etc., or as a company if you want to start contributing. A couple of highlights that we're going to have. We're going to participate in a few events in the near future, but we will have an Open19 Foundation annual event on the 3rd week of May, and we will encourage you to come and join. We will have a 2-day event. The first day will be a hackathon day where people can come and hack on the system, hardware and software at the same time, and we'll get prizes for the winners of the best hacks of the day. Second day, we'll be able to actually meet all the participants in the Open19 project, the partners, the people that will build technology, and we'll have a showcase on the floor as well to show the technology which is related to Open19 and extensions of projects technology for companies which are involved with this. I want to thank you for taking the time for listening to this podcast and webinar, and I will open it up right now for questions. If anybody has a question, please post it into the chat, and I will start with the first question that came in. Is each server quad socket, 6 cores, 6 containers? So what is 6 container per core? Container system is a system which runs under Linux and enable you to run multiple containers for every core on a server. Those containers enable you to run independent sub functions on every server. We are running between 0 and 6 to 8 containers per core, which enables us to extend the power of every one of the servers. The next question I've seen is, can we get everyone? Oh, I guess that's not a question.
This is like.
This recording will be available afterwards. We will post it into the Open19 public area where you can actually be able to see that and go through the video flow as well as the audio flow. The next question is, what kind of network adapter are you using and recommend to generate the 100 gig. Today we're using most of our servers are using what's being called in the industry OCP mezzanine cards. You can buy them from multiple suppliers. Mellanox and Broadcom are the primary ones who are supplying those NICs. But in general, you can use any NIC which is in any server. Some of our server partners are using NICs which are not NICs, standard NICs, but they're specialty NICs that they built. The only thing they need to do is adapt that interconnect to the backside of the blind main. I think the first servers that we've seen in the industry were just jumping from a standard NIC into an adapter card, which did the adaptation into the blind main connectivity. The new generation of servers that we're seeing emerging in 2018 actually have the connectors of the Open19 embedded into the motherboard, so the NIC does not have to jump into the motherboard.
Log in and see once I can get to the log.
Who's the primary partner for the PowerShell? Currently, the primary partner for PowerShell is Delta, and we're working closely with Schneider to actually enable a second source for the PowerShell.
There should be something.
So this is 1%. Okay.
Oh,
so
that I don't actually.
And there's a question from guest 2 saying
okay.
perforation of the top cover, question mark. I'm not really sure. I assume that you're asking is why the top cover is perforated, and that is to enable us to create better airflow. Since we vent only on the backside, we don't vent either to the top or to the sides. We'll have to perforate some of the top portion of the top cover. I assume that's the question. So if it's not, just resubmit your question. Will you be working with resellers to make this available
Oh, you know what? Let me
to service provider or less companies like Rackspace or the likes? Absolutely, yes. This is an open source environment. This open source environment will enable us to work with anybody. Like I said, you can already pre-order the technology and get a proof of concept from Flex and be able to work with them to get this technology. There is no restriction on where this thing going. Like I said, some of our partners are integrators which work directly with companies which are mid-size and below. Some of them are direct rack and roll environment, and some of them are our service providers and data center operators. This technology applies to everybody, and you will be able to sell it through resellers once it's completely finalized and released to production. Like I said, the two partners we have right now for producing the technology is Flex and Celestica, where Flex is primary. Resellers that are interested in continuing to resell the technology should reach out to those two suppliers and see if they can get into engagement with them.
Unless this is actually physically.
Question: are you planning to support on supporting other kinds of external connectors on the bricks? The answer for that is absolutely yes. We are working right now on future developments for the next generation of the Open19 platform. Some of those connectors will be actually optical. We will not support a secondary copper solution, but we will definitely support an optical solution that will enable to go to much higher bandwidth to the server, as well as go with integrated opticals into the servers that will give us the future for higher bandwidth per server and a more optimal data center networking connectivity. But like I said, just to clarify, no other copper solutions will be actually supported at this point. We believe that the copper solution we have will take us up to 200 gig per every half U, scaling linearly like I was explaining, so there's no need for us to look for different copper solution connectors.
Connectivity.
Could you please mute? Okay.
Licensing all kept running, but they couldn't communicate with all the key lines on this old Cisco network segment. And if you look at all the key lines in their logs, all of them say lost communication with the server.
Okay. The next question is, how much heat do the system put out when it max capacity? So it heavily depends on your application. but the application is built today for 9.6 kilowatts for every 2 cages that we put with a PowerShell and a switch. So the assumption is that the heat that will come out from the backside is going to be reflective of that. We do have a spec for the server suppliers of what is the max temperature increase that they are allowed from in to out, and that is 15 degrees C. So if you are in an environment that you are operating at 45 degrees C, that most people will not operate, the temperature you will see outside, the max temperature you see outside is 60 degrees C coming off the server. Most of the data center are operating at area of 25 degrees C, so the max airflow temperature that we're going to see coming out of the back is going to be at 40 degrees C. I hope this is answering your question. If not, please re-put the question. Accessing the next question is about accessing the recording. The recording will be posted into the Open19 Foundation site, and the Open19 Foundation site has a public space where we have videos and other media. This is going to be posted over there. So the next question is, where can other vendors reach you to be included and start testing their own products? So there are 2 ways to do this. One is, the best way is actually come through the foundation, join the foundation, and start working with the foundation to actually present your technology. You can also access LinkedIn directly, which is the first company which is doing high-level adoption. And if you have technology which is Open19 compatible, reach out to us and we will be able to help you with that. You can do it through the foundation or directly to LinkedIn. Either way works, and we'll help you with that. You will see adoption from other groups like G Digital, which is sitting on our board, will start doing adoption. So some of the technology might be applicable for them. So you can reach out directly to them. At this point, we don't have like a centralized area where we do marketplace for the technology. So if you don't have a centralized area, you'll have to reach out to your customers directly. The question is, the next question, are there specific bricks defined for storage, specifically flash and SSD? The answer to that is yes, for sure. We are working on compute storage and specialty servers in this form factor. There will be dedicated servers which will have very high density of disk drives, 2.5 inch and 3.5 inches, to be able to create universal environments. So the answer, I can't give specifics over here, but the answer is definitely yes. We will have specific storage servers which will have high density 3.5 and 2.5 spinning SSD and NVMe drives in them. The next question is, can you talk more about the speed of the NICs? Will it be 25 gig or 25 gig or 50 gig or both? So the definition of the way the solution is built right now, each one of the bricks can actually push 50 gig. Now, to push 50 gig today, you need to basically drive into the backplane 2 channels of 25 gig. 2 channels of 25 gig enable you to drive 50 gig as a single port, and that's where the 50 gig NICs come into. You don't have to push 50 gig to the back. If you want to use a NIC which is only 25 gig, you can use only one of the channels out of the 2 and drive only 25 gig to the server. It's completely in the choice of the configurator of building the servers or the end users who's buying the servers, what NIC they need to do. The one thing that we will have a very difficult time supporting is 10 gig NICs. So for this technology, the entry level is going to be 25 gigabits per second per server. Next question is, are there other projects initiated or opportunity to collaboration? So the Open19 Foundation is not just about the Open19 projects. While they share the name, Open19 Foundation actually has a lot of aspects to it. It's open for hardware and software projects. They are already in the pipeline, 5 projects. 3 of them are software projects, which are related to management, related to control, related to network operating system. They're all in the pipeline to come into the foundation. The one big project is the Open19 project, which defines the form factor, and there's another project which is coming in as a server project, which is also related to Open19, but it's an independent server project. We encourage everybody to come and contribute to the foundation and initiate projects which are associated with the Open19 project or not associated with the Open19 project. We are building a community of open hardware and software, so please feel free to join and actually participate in any of those projects. We have 2 types of projects in the foundation. The first type is a project which is called the Soul Company project, which is you come and contribute to your project. The other one is collaborative, and you can create collaborative projects with other companies and still have a significant and very good platform to share, but at the same time, IP protection for IP. If you need more information, go to open19.org, read the bylaws, or register as a company, and you will get the full package of the information. Is redundant networking planned this platform? So initially, we looked at the solution that will have a dual switch. It did not seem, based on the based on the partners that we have, it did not seem like a very strong requirement. So we did not build ahead of time a technology would enable it to do it. However, since those cables which are snapping on the back are extremely simple to implement, if you want to implement a dual TOR configuration, you can. You just need to actually create a new cable for the back. That new cable is going to be a specialty cable that on one side will terminate the server, and on the other side will enable you to actually connect to 2 switches instead of only 1 switch. This can be an extension to the Open19 project, which definitely we want to encourage people that believe that it is important for them to do that, to actually start this project and move forward with it. In that case, by the way, you also can put 2 NICs in the server itself and actually drive 2 NICs, or if you want to drive 1 NIC and split it into 2 switches, you can do that as well. The next question is a plan to have a special GPU servers? The answer is absolutely yes. Part of the reason that we had the specialties form factor, which is a half-width 2U, is exactly for that, to accommodate modules which are GPU modules that require a little bit more height. And we're definitely working on this in this direction. If you have a specific need for that, we'll be happy to have a discussion and actually move it forward together as a development with whoever is your partner, if it's NVIDIA or AMD or anybody else. Last question that I see over here are the 3D drawing specs are shared. So they're not shared yet because we have not completed the full contribution to the foundation. LinkedIn is in the process of cleaning up right now the package that we want to give, and they will be completely shared. What we will do over here is 2 levels of sharing. There's going to be the first level of sharing, which is for knowledge, right? Specs and PDFs, etc., similar to what other organizations are doing. But we're also going to have a level of package which will be only available for members of the foundation because they need to be under IPR rules. And that package will be a fully reproducible package, which means that you can take it, move it to your favorite ODM and say, hey, build it for me. And everything is going to be in there. Everything means everything. FPGA code, software, BIOS code, everything that you need to actually be able to reproduce it is going to be there. So I want to make sure that everybody knows that will be the case. We will be releasing this soon. We don't have an exact date exactly when this whole data is going to be out there. If you feel that you need early access, please reach out to the Open19 Foundation and ask for early access for the information, and we'll try and help as much as we can with early access to the information. The next question is, if a cable becomes faulty once it is installed, do you need to replace the bundle or can you replace just a faulty cable? So if you saw the cable, the way it is defined, the cable is a harness, and I'll jump back quickly to the harness picture. This is a harness. You can see the picture. It's actually connected to 12 servers and 1 aggregation. This cable, since it's actually doing snap and a backplane function, chances of this failing is really, really low. However, if a failure does happen, and failures always can happen, unfortunately in this configuration you have to replace the whole harness or give up on a slot. Those are the two things that you can do. There is no way to replace a single connector on the snap because it's actually completely tied into the spine. Okay? Jump back to the next question. Oops. The next question is, can you share what LinkedIn's timeline ramp role into the in Open19 in our data center? Unfortunately, I cannot share that information. Like I showed in the picture, we are already in the data center, which means that we are there already. I can't really share information which is confidential for LinkedIn about the timeline and ramp that we have for the technology, but we are trying to do this as soon as possible, and we will probably be able to announce more information down the line. Stay tuned to the LinkedIn information that will be given over the wire or in blogs, and we'll talk about our deployment experience and our volumes. We do expect this technology to ramp with our partners to relatively high volumes of hundreds of thousands a year, but that's depending on our partners, depending on our ramp, depending on technology availability, etc. So unfortunately, I cannot comment on ramping or timelines, but I believe, and we truly believe together, that this will be a high volume environment. When in May is the conference? The conference has been announced on the website. The conference right now is targeted for May 22nd and 23rd in the Bay Area. Can you speak more to Microsoft's commitment to Open19 Project post-acquisition? So I cannot speak for Microsoft, that's for sure. I can speak to LinkedIn. LinkedIn is committed to the Open19 project, and LinkedIn is working very hard to make the project be successful. Microsoft is supporting us in what we're doing right now, and Microsoft is even doing a project which is shared with us to integrate some of the Microsoft technology into Open19. That's all I can do. I can say this is not representing any Microsoft view. It's only representing LinkedIn's view that we are doing everything that we can to make the Open19 project successful and deployable. Any other questions? I don't see in the chat any additional questions, and we're almost on time. Let's give it another 5 seconds. Okay, one more question. Can you talk about the 7 servers vendor? Yeah, so we have partners, multiple partners for server technology in the Open19 Foundation, and some of them working directly with us, some of them are working indirectly with us. The names that are already public in the Open19 Foundation are Flex, Celestica, Inspur, HP Enterprise, Supermicro, and a couple more that I cannot mention right now, which are building servers for this Open19 technology. And we believe that in the future, we will see this technology actually coming from almost every server supplier you see in the world. If you are an end user, ask your supplier of servers to actually give you servers in Open19 form factor if you believe this is the right form factor for you, and they will produce it for you. Question about any public documentation about the PowerShell you showed in today's slide. So the power module that we're using is a off-the-shelf power module, 3.2 kilowatts from Delta. So you can go and see the power module specs online. The PowerShell itself, like I said in the status, we are working to bring it into production state. Once it's going to go to production state, there will be a spec out there which is referring to the hardware implementation, connector location, connector types, software APIs, etc. Any other questions? If not, one more. Oh, thank you. If not, we're right on time. I want to thank you again for listening to the webinar today. I hope it was valuable for you, and hopefully we'll be seeing more collaboration from you. I hope that I was able to answer most of the questions that you had over here, and that will give you a path to actually consider Open19 as the future for your data center needs in the edge or in the data center itself. If you have any additional questions, you can reach out to me directly, Yuval at LinkedIn or Yuval at Open19.org, and we will try and answer as fast as possible every question or every inquiry that you have. Encourage you as individuals to join the foundation, and if you believe this is technology which is valuable to your company as a supplier or as an end users, I want to encourage you to work with your company leaders to actually join the foundation as well. Thank you very much, and with that we'll close the webinar, and like we said, we will post this into the Open19 website as soon as it's complete. Thank you.